Welcome to Electrical Design Management's instruction video for the three-phase motor calculator module. Let's get started. First, we select the electrical code we want the program to use. If in the United States, select the National Electric Code, or if in Canada, select the Canadian Electrical Code. Just a comment on the two codes. Both are very similar when dealing with the motor sections of the codes. The major difference within the two codes is the US code uses imperial units and the Canadian code uses metric units. Although there are some other minor differences, EDM takes these into account when the code is selected and used in the program's calculations. Next, we choose the motor's identification tags and function description. Our example here shows the motor's identification tag along with its function description. These identification markers are used by EDM throughout the design of the motor. These markers are used by the different EDM modules, for example, cable schedules, processing and non-processing equipment schedules, electrical single-line diagrams, estimates, and so on. Moving along, we now must make some design choices for the motor. But first, some background on how EDM handles these choices. Every motor is designed to a specific code, depending on the load it's required to move, and whether the load is a continuous or zero start load. These codes are identified by a letter symbol, either A, B, C, D, or E. The motor design code B is the workhorse of the motor industry, and EDM bases its calculations on this code. We move on to the selection of the horsepower rating, voltage, RPM, and the duty cycle of the motor. Its straightforward selections and drop-down lists give the ranges that the program offers. These ranges are the most common motors used in industry. The RPM selection is from the performance data sheets of one of the largest motor manufacturers in North America. There are a specific number of choices for RPM values associated with each motor. Once these selections are made, the program calculates the required data to determine starter size, breaker or fuse protection, cable size, approximate cost per unit, and operating cost of the motor. Before we move on, some clarification as to how EDM determines ampere designations such as full load amps, full load current, and running load amps. During design stage, EDM calculates the maximum amps of the motor running at full load using the standard formulas. EDM refers to this as running load amps. This is used to determine the starter size and breaker or fuse protection of the motor. The running load amps are sometimes referred to as full load amps, or FLA. However, the full load amp designation is determined when the motor is tested after manufacturing is complete. Each motor will have a unique FLA rating depending on the manufacturer, materials, etc. Once determined, this value is then added to the nameplate. EDM's goal is to bring the design stage of the motor calculations as close as possible to the manufacturer's FLA nameplate rating. Also, each motor has a service factor designation, ranging from 1.15 to 1.25, depending on the manufacturer's design. This being the case, the National Electric Code and the Canadian Electrical Code have determined to add a multiplier of 1.25 to the running load amps to incorporate this added load. This value is the motor's full load current value and used in the cable calculator to determine the cable size for the motor. EDM has the ability to save and store your projects and control centers on your own personal drive located on our secured server. In our next video, we will look at the cable calculator portion of the three-phase motor module. See you there!